let's do a few examples of adding hydrogen halides across a double bond. So, for the first one, 1-phenylpropene. We know a phenyl group is basically an aromatic ring. So here is my propene, 1, 2, 3. Here's my double bond, and I have a phenyl group. Okay, I'm going to add HBr. Okay, so, and I have a peroxide. So once I see the peroxide, then I know, oh, well, what's going to happen is I'm going to add anti-Markovnikov, right? So how do I do this? Because if you look at this, say, wait a second. That has one substituent. That has one substituent. So how do I know what my regiochemistry is going to be? So if you look at it, if I form a radical here, okay, and I add in my bromide there, then that's a secondary radical. If I add in my bromine here and I form the radical here, then I can actually have resonance stabilization here. So the radical at this position will actually be more stable. So what I'm going to do is I'm going to add in my bromine here, and I'm going to add in my hydrogen there. Oops, I want a 6-membered ring. I'll just write phenyl. Okay, so this would be my major product. Okay, again, how do I know this? If you look at your two choices of your intermediates, and it's really important that you take the time to take a look at your intermediates. One intermediate, if I put my bromine here, I'd have a radical there. Well, there's no stabilization there. It's just a secondary radical. If I look at my other radical, it would look like this. And with this, if I draw in all the alternating double bonds in my aromatic ring, we've worked on resonance since the beginning of the semester, and you can see that this radical gets distributed. There's a pathway across this aromatic ring. So this is more stable. So we know that this is going to form. That'll be my product. I'll have a hydrogen there. Okay, so that's how we handle the first one. Okay, so let's take a look at the second one. Convert 1-methylcyclohexene to 1-bromo 1-methylcyclohexane. So what do? So let me just squeeze in here. 1-methylcyclohexene. So here is my cyclohexene. 1-methylcyclohexene. Okay? And I need to do something to turn it into a 1-bromo 1-methylcyclohexane. So if you look across this, then how am I adding it? I'm adding an H here, and I'm adding a bromine there. This is a Markovnikov addition. So all I need to do this conversion is to add HBr, and it will automatically do my Markovnikov addition. Okay? So when you are assessing how to do this reaction, take a look at your reagent, take a look at your product. You have to say to yourself, hey, I don't have a double bond. I have a double bond. So I added something across my double bond. Okay, so one, you know we're doing an addition. Then you have to say, I have a bromine here and I added a hydrogen there. So I added HBr. So now you know that's my other reagent, HBr. Now, since we know we're adding HBr across a double bond, we have to consider regiochemistry. You say, okay, So H is my electrophile, right? Because HBr, H plus, Br minus. H is my electrophile. It went on the carbon with the most hydrogens. That's a Markov-Nikov addition. So because of that, we don't need to add any peroxide. We just add in the HBr and we get our Markov-Nikov product. So before you go through and start putting together your reagents, figure out what's the difference. Now that you know the difference is HBr, you know you've got to add that in there. That's got to be one of your reagents. And because you know you're doing an addition across a double bond, we have to worry about stereochemistry or regiochemistry. In this case, it's regiochemistry. We have to worry about Markov-Nikov products. Do I have to worry about stereochemistry? This is basically achiral, so I don't have to worry about that. Do I have to worry about stereochemistry here? The answer is yes, I do, because isn't that a chiral carbon? But it turns out, since I started off with something that was sp2, I would be getting a racemic mixture here. So, we draw it flat. That looks good. Make sure you are aware that you are forming a racemic mixture. Okay? So, let me erase this and give me space for 3 and 4. Okay, so let's take a look at number 3. 1-methylcyclohexene to 1-bromo 2-methylcyclohexene. So, here's my cyclohexene, 1-methylcyclohexene, and I want to figure out, might be more than one step now, so we have to bear in mind how many steps we're going to do. To 1-bromo 2-methylcyclohexane. Okay, I'm drawing it this way just because of the name, 1-bromo 2-methylcyclohexane. But now I'm going to do magic. And what's this magic? I don't have to draw it this way. What happens if I draw it this way? One bromo 2-methylcyclohexane. I'm changing the way I just number it. Now, why did I do that? Because look at, now I can compare. If I compare, the methyl stays the same. What did I add? I added HBr. I added a hydrogen here, and I added a bromine there. So you know that when I do this conversion, this synthesis, I have to add HBr. Okay, so now I know what I've added, but now I have to go through and say, okay, now H, this is H plus, Br minus, right? At least that's what it looks like it should be. But if that's the case and that's my electrophile, shouldn't it go here? Isn't that what we just did, where it should go on the carbon with the most hydrogens? But it's not. It went on the carbon that had the fewer hydrogens. This is an anti-Markov-Nikov product. Okay, and because it's an anti-Markov-Nikov product, now we have to figure out, how do I get an anti-Markov-Nikov product with HBr? And the only way you can get an anti-Markov-Nikov product is you have a peroxide of some sort, and you have heat. So this is how you add HBr in an anti-Markov-Nikov fashion. So that's how we do that conversion. There you go. Okay. The key to doing any of these types of syntheses is always make sure you compare what you want with what you have. Okay? And then from there, you can figure out what to do. Now let's do number 4. We're going to convert in number 4 2-methyl cyclohexanol. So let's draw our cyclohexanol. There's my alcohol group, 1, 2. There's my methyl group. And we're going to make 1 bromo, 1 methyl cyclohexane. 1 bromo, 1 methyl. Okay, and we have to figure out how to do this. Okay, now this is a retrosynthesis. They all were, but this one has multiple steps. So that's why we know that we had to come up with the steps here. And again, like I did before, instead of keeping it here, I'm going to redraw this. Let me show you how I'm going to redraw this. See this methyl group? See that methyl group? I'm going to draw it so it's in the same orientation. Then I can compare the two. So 1 bromo, 1 methyl cyclohexane. So when we do this, how do I go from here to there? Well, let's talk about what you know. We know how to put a bromine across a double bond. Or we know how to substitute a bromine with a hydrogen here. Well, we can put a bromine across a double bond. So let's talk about what we know. We can add HBr to an alkene. And we can do a bromination on an alkene. Okay? So, an alkane, that's going to be harder to do. Okay? Because I don't have an alkane. And I haven't really talked too much about how to get rid of an alcohol and form an alkane. But can I make an alkene? So, let's see. Ways to make an alkene. So, we know how to make an alkene through E1 and E2. E1, dehydration. Oh, wait a second. Let's stop there. Dehydration of an alcohol. So, we know E1, E2 on, this is what, all the ways we know how to make an alkene. I don't know how to make an alkene. So let's go with the alkene. With an alkene, the alcohols, the E2, we've always been using alkyl halides. But E1, we also talked about dehydration of an alcohol. And I have an alcohol, so we're not going to do E2. We're going to do E1. So the first thing we have to do is take my alcohol, dehydrate it, and make an alkene. The second thing we need to do is add HBr. And since this is a Markovnikov addition, we're okay. We don't have to worry about doing an anti-Markovnikov. So this is a Markovnikov addition. So you can see how when we do this type of synthesis, we're thinking backwards. And it's really important now that we're doing all these reactions that you list all the ways you know how to make something and all the ways you know how to react them. Okay? It goes back and forth. So we know addition's the opposite of elimination. We know all the different eliminations. And keep listing them because this is becoming your tool set. And with your tool set, this is how you're going to decide the order in which you're going to use them. Okay? So let's go ahead and put this together. All right? So if I take my alcohol and I do a dehydration. So we're going to add something like, oh, you know how to do this. We've added sulfuric acid and then we heat it. Okay? What happens is you lose your water, then you get a hydride shift, form your tertiary carbocation, you get this product or that product. This is not the most stable because that's not a Zaitsev product. The Zaitsev product goes here. So you know what you're going to get is that. Okay, so let me just finish your synthesis. That's step 1. And then after we finish the synthesis, I'll put notes on the mechanism below. Then step 2, if I add just HBr, okay, then the hydrogen goes here, bromine goes there, and now you get your final product. So this is a 2-step synthesis. Okay, so let me just move down a little bit here. Let's focus just a little bit on your mechanism. Okay, so the first one, remember, for your mechanism, okay, you're going to protonate this, and you're going to lose your water, so you get a hydride shift. And then basically your water comes in, regenerates my H+, and now that's how you form your alkene. Okay? Why here and not here? Because remember, if I lose this one, I'll put that one in pink. If water comes here, the product I can form is this. Okay, and we know this has 1, 2, 3 substitutions on my alkene. This one has just 2. This is more stable. Okay, so this is my major product. All right. And this has to do, if you like names, with Zaitsev's rule. Okay? And now we go to, in blue, let's take a look here. When I add HBr, if I add H here, you're going to form a tertiary carbocation, which is more stable than your secondary. If I add H here, then I'd form a secondary. And then now your bromide can attack and you get your final product. So this is a 2-step synthesis to go from, this is 2-cyclohexanol to 1-bromo, 1-methyl cyclohexane. Okay, so that's it for examples, and we'll start on our next section.